Today we're talking about growth and decay models, like the actual formulas and looking at some problem solving and some word problems. The growth model, note growth, is y equals a times 1 plus r raised to the t. 1 plus r, everything inside the parentheses is the growth factor, and r is the rate of growth. The rate of growth is a percentage. So if it's a 12% rate of growth, we must put that into the formula as a decimal. That would be the decimal 0.12. Whereas if it's a 5% growth, that would go into the formula as 0.05. If you are struggling with converting from percents to decimals, remember that you can put your percent divided by 100 into your calculator, and that will tell you the decimal that you need to use. A is the starting amount, so you should probably label that A is your starting amount. The decay model is honestly exactly the same as the growth model. The only difference is it says 1 minus R. Same thing, R is the percent for the decay, A is your starting value. Okay, we're going to look at example 4, but we are not going to do part C. The value of a car in thousands of dollars can be approximated by the model y equals 31 times 0.92 raised to the t, where t is the number of years since the car was new. Tell whether the model represents exponential growth or decay. Honestly, you don't need these formulas to figure this out. We talked about this yesterday. Look at the number raised to the exponent. That number is less than 1. That means that this is a decay model. Identify the annual percent increase or decrease. Well, we're not going to do increase because this is a decay. This is the kind of tricky part. So 0.92 is the decay factor, but we want the actual percentage that was used. That 0.92 is inside the parentheses. That came from 1 minus the rate. 1 minus r gave us 0.92. So if we solve that equation, if we subtract 1 on both sides and then divide by -1, we end up with 0.08. which means an 8% decrease. Basically, think of it as 0.92, we're keeping 92% of the value, which means we're losing 8% of the value each year. Now we're going to skip example C because it's just extra work that we don't really need to do. We're also going to skip example 5. I want to get to the good stuff so you have time to get your assignment work done. In 1980, about 2,000, oh my gosh, what should that number be? That should be 2,180,000. Looks like we left off a 0. 2,180,000 U.S. workers worked at home. During the next 10 years, the number of workers working at home increased 5% per year. Write a model giving the number W in millions of workers working at home T years after 1980. It says that it's increasing, which means we want to use the growth model. The growth model is y equals a times 1 plus r raised to the t. The initial amount, that would be the 2,180,000. They want us to write this in millions. That would be 2.18 million. Honestly, don't worry about the growth factor. I want you more to think about the percent increase. It's 5% increase per year. We are going to use the decimal 0.05. Now we need to write the model. Our starting amount is 2.18 million times 1 plus 0.05 raised to the t. If you want to leave it like that, that's totally fine. If you want to simplify it so that it says 2.18 times 1.05 to the t, that works too. Okay, these word problems are really not very difficult. Look for the word increase or decrease. That will tell you whether to use the version of the model that has a plus for increase or a minus for decrease. Find your starting amount, find your percent, plug it in. Estimate the number of workers working at home in 1990. It says up here T years after 1980. So we have to think about from 1980 to 1990, how many years is that? That's 10 years. So we are going to use a T value of 10. And you're going to plug this into your calculator. Y equals 2.18 times 1.05 raised to the 10th. If you're entering this in your calculator, you need to keep in mind that you have to do exponents before multiplication. So if you're going to enter it in step by step, do the exponent part first, then multiply by 2.18. 2.18, and I really like the graphing calculators for this because you can type it in and make it look exactly like it does on your paper. This would be 3.551. And remember, this is in millions. So 3.551 million workers working at home in 1990. If you wanted to change this back to a number, that would be 3,551,000 working at home. All right. There are 40,000 homes in your city. Each year, 10% of the homes are expected to disconnect from septic systems and connect to the sewer system. Write an exponential decay model for the homes that still use septic systems in 10,000s. Decay model, we're going to use y equals a times 1 minus r raised to the t. It says decay, that means you use the version of the model that has subtraction. You need to know what a is. Our starting value is 40,000 homes. And 10%, we will use a decimal of 0.10. Okay, now it says in 10,000s, but honestly, let's cross that off. Let's just use the whole number. We can put a bunch of zeros in it. That's not going to be a problem. So y equals our starting amount, 40,000, times 1 minus 0.10 raised to the t. If you leave your answer like that, it's not necessarily wrong, but you can simplify this into 40,000. 1 minus 0.10 is 0.90 raised to the t. Once you have the model written, the next step is just to use that model. Use the model to estimate the number of houses using septic systems after 5 years. That means we are going to use t equals 5. So 40,000 times 0.90 raised to the 5th. 40,000 times 0.9 raised to the 5th. There will be 23,620. 23,620 homes using septic systems after 5 years. Okay, that's the growth and decay models. Excuse me. There are some problems like each of those on your worksheet. There's also the compound interest formula. Compound interest formula, it really is just the growth model. P is your starting amount. They call that the principal. It's the amount that's deposited originally. A is like your ending amount, which we aren't really going to get to until later. So A is like the number you're going to get when you plug things into your calculator. R is still your interest rate written as a decimal. And N is the number of times it's compounded in a year. And T is the number of years. how many times it's compounded in a year. This is kind of weird. If it's compounded annually, then n is 1. It's compounded once in a year. So once every year, they calculate the interest and add it in. If it's calculated monthly, you would use an n value of 12. Once every month, 12 times a year, they calculate the interest and add it in. Quarterly, how many quarters are in a dollar? 4. There are 4 quarters in a year. So once every 3 months, they calculate the interest and add it in. Weekly, there are 52 weeks in a year. Bi-weekly, I will never ask you because depending on who you talk to, some people say bi-weekly is twice a week, in which case it would be 104. Other people say that bi-weekly means every other week, in which case it would be 26. So since there's confusion there, we're just not going to use bi-weekly. And daily would be 365. You deposit $2,300 in a bank account. Find the balance after 3 years for each of the following situations. And our first situation is 3.5% annual interest. And let's do compounded quarterly. So $2,300, that is our principal. 3 years, that is our T. Our interest rate is 3.5. That'd be 0.035. Remember, you move the decimal point 2 places, so 0.035. And quarterly means we are going to use n equals 4. Let's throw all this into the formula. The amount that we are going to have equals what we're starting with, 2,300, parentheses, 1 plus r, our rate, divided by n, 4, raised to the 4 times the number of years, 3. You're going to plug this into your calculator basically exactly like that. 2,300, parentheses, 1 plus 0.035 divided by 4, close your parentheses, raised to the 4 times 3. Now, if you're using a scientific calculator, you may want to actually do that 4 times 3 in your head and put 12, or put raised to the parentheses 4 times 3, close your parentheses. Remember, parentheses are your friend. Our answer is $2,553. And then think about how we round money. It says 0.467. So 46 cents, the 7 is going to round that up to 47 cents. Make sure that you are practicing correct rounding. I would like you to try the next one. Again, it's $2,300. That's your principal. Find the balance after 3 years. That's your time. Here's your rate. I want you to think about what that rate would be. And let's do compounded monthly. So pause the video, try to put this all into the formula, and then play the video after you are done to check your answer. I'm serious. Pause the video. Pause the video. Pause the video. Have you paused it yet? You need to pause the video. Pause. Pause, please. Pause. First, check your interest rate. Did you use 0.0195? If it's a single digit with decimal, make sure you have 0.0 something something something. It would be 2300 parentheses 1 plus 0.0195 divided by 12 raised to the 12 times 3. Did you put everything in correctly? Check to make sure you put it in the right spot. Now practice putting it in your calculator, see if you get the same answer I do. Here's what I put in the calculator, and I got $2,438. And then let's look at the cents so we can see how to round it. Currently we're at 44 cents, but the 7 that comes after is going to bump that up to 45 cents. Our answer is $2,438.45. And we're going to skip that last one. Work on worksheet 4. You can work together to compare your answers.